Welcome to Mrs. Miller's notes for her pre-calculus class. These are the notes for section 5.1, day 2, entitled The Unit Circle. And today we're going to continue talking more about the terminal points on the unit circle. We had talked about some of them for the degrees around the unit circle yesterday, so today we're going to talk more about the terminal points for the radian measurements. And we're just going to start with a few proofs, I guess, in a way. We're going to find the terminal points for 3 of the main radian measurements around the unit circle. We're going to start with pi over 4, and then we'll do pi over 3 and pi over 6. Okay, now if you remember from the previous section of notes, the terminal points on our unit circle, if we just draw a little axis here, and we've got our unit circle that goes around. We're going to focus mostly on the first quadrant here. Okay, so we've got our terminal point there, which is 1, 0. And we have our other terminal point up here, which is 0, 1. We've got our x-axis and we've got our y-axis. Okay. Now, remember, this was 0 degrees and 0 radians. And then this measurement up here was 90 degrees, or pi over 2 radians. So we want to find the terminal point that's right there at pi over 4. It's halfway between 0 and pi over 2. So if we think of it like this, okay, there's kind of like a little line there, that little dashed line. Okay, that's our 45 degrees. That's pi over 4, or 45 degrees. So it's a 45-degree measurement in there. And there's a couple different ways that we could think of this. I think the easiest way is possibly to think of it as a reference triangle. Okay, if you think back to geometry, you had your 45, 45, 90 reference triangles, and we used them a lot with Pythagorean theorem, so we could save time and not having to do Pythagorean theorem with 45-degree angles. And then we used them a lot for sine and cosine and tangent as well. But if you have your 45 and your 45 and your 90-degree triangle here, hopefully you remember your side measurements for this type of a triangle. Okay, since these two angles are the same, that means these two sides have to be the same, and they were 1 unit long each. And then the hypotenuse, if you do Pythagorean theorem, you have 1 squared plus 1 squared equals something squared, and 1 squared plus 1 squared is 2, and then the square root of that would be the square root of 2. So that's how we came up with those side measurements for that reference triangle. And we're going to use that here in our unit circle as well. So if you think of this as being a 45-degree angle, and then you kind of have like this little leg that drops down, right in here, this is your 45, 45, 90 triangle. Okay? Except the radius on this triangle, or I'm sorry, the hypotenuse on the triangle, this hypotenuse here is the radius of our circle. And on a unit circle, the radius has to be 1. Okay? So if we have our 45, 45, 90 triangle, and if I have these measurements, 1, 1, and the square root of 2, you have to think, okay, how do I make the square root of 2 equal 1 somehow? What can I do to it to make it equal to 1? Well, divide it by itself. So I have to do that to all the sides on the reference triangle. So now in my unit circle here, this distance is 1, and then this is 1 square root 2, and then this leg over here is also 1 square root 2. Kind of smush it in there. So this is the distance that I'm going to be traveling on the x-axis, and this is the distance I'll be traveling on the y-axis to get to my terminal point at pi over 4 degrees. So this is the center of my circle. That was 0, 0, and then this is my terminal point. So I'm going to travel 1 over the square root of 2, and 1 over the square root of 2. However, I can't leave a radical in my denominator. That's not allowed. So I have to rationalize it. I have to multiply by the square root of 2. So it's really the square root of 2 over 2. So that's really the distance we're going to be traveling. So really, that terminal point then is going to be the square root of 2 over 2 and the square root of 2 over 2. So that's this point right here at pi over 4. Now, you can also figure this out by doing a little bit of algebra and using your equation for the circle. Okay, we've got x squared plus y squared equals 1. Now, we know that 45 degrees is halfway between 0 and 90. Okay, so we know that x, our x distance, has to equal y. Okay, so if I know that, then I can really just substitute x for y, because those distances are going to be the same because I'm going halfway between 0 and 90. Okay, so the distance that I'm traveling here and the distance that I'm traveling here, they're the same. So I have x squared plus x squared is 1, and now I can just solve this. 2x squared equals 1. So x squared is a half. And when I take the square root of that, then I'll have 1 over the square root of 2, which I have to rationalize. So I get square root of 2 over 2. And if x is equal to that and x is equal to the y, then y is also equal to square root of 2 over 2. Okay? So there's two ways that you can think your way through this and kind of find the terminal point for pi over 4. But you just need to know from now on, when we're using our unit circle, that that terminal point is going to be square root of 2 over 2 and square root of 2 over 2. Okay, so next we're going to find the terminal point for pi over 6. Okay, now again, on our unit circle, that pi over 6 distance, remember there to go from our starting point here and go halfway around, remember that was pi. So if this is pi over 6, that means I've cut this into 6 sections. Okay, so pi over 6 is going to be right there. That's 30 degrees. So here I'm going to use my 30, 60, 90 reference triangle to think through this. Okay, now I want 30 degrees to be at the bottom of the triangle here, because this is where that little triangle gets dropped in my picture, just like before. Okay, so I've gone up 30 degrees from my starting point on the x-axis. Okay. Now, the measurements on the 30, 60, 90 reference triangle, the hypotenuse always had some kind of 2 in it for the reference triangles. Okay, this one happens to be 2, the other one was the square root of 2. The side that was between the 90 and the 60 degree angle is a length of 1. And then the side that's between the 30 and the 90 degree angle was the square root of 3. So I always remembered that the 3's kind of go together. The 3 and the 30 and the square root of 3, they kind of go together. Okay, but again, this distance here would be my hypotenuse on my triangle. And that would also be the radius on my unit circle. So I can't really have a radius of 2 on my unit circle. I have to have a radius of 1. So again, you have to think, okay, what can I do to 2 so that it's equal to 1? Well, divided by itself. 2 divided by 2 is 1. So that means I need the square root of 3 to be divided by 2 and 1 to be divided by 2. So these are my measurements that I'm going to use for this old red triangle in my unit circle. So then the distance that I'm going to travel to get to the terminal point right here at pi over 6, I'd have to go over square root of 3 over 2, and then I'd have to go up 1/2. So that would be the terminal point right there of pi over 6. So square root of 3 over 2, 1/2 is going to be the terminal point for pi over 6. Okay, so I'd have to go over square root of 3 and up 1/2. Now, you can go through this algebraically, just like I did on the previous slide. It's really complicated though. If you want to see it in class, I can show it to you in class, but it's going to take a long time to go through it. But if you want to see it, ask me about it in class, and I can show you the algebraic way to go through that. Okay? So we have two of our terminal points so far. We have pi over 4 and we have pi over 6. Now we just need the terminal point for pi over 3. Now, when we do that, there's a connection between pi over 3 and pi over 6. It's on our unit circle. Okay. When we did pi over 6, we cut that first semicircle in our unit circle into 6 sections. If I'm doing pi over 3, I'm going to cut it into 3 sections. Okay, so I would cut it here and here, and then of course I have my axes. Okay, so here's a 1/3, there's another third, there's another third. Okay, so those overlap my other slices, I guess you could call them, that you would make for every 30-degree or every pi over 6 increment. So there's a connection here. Okay, but I am going to be finding the terminal point for right there. That's going to be pi over 3. So again, I have to make a little triangle here. And pi over 3 is going to be 60 degrees. So I'm using my 60, 30, 90 triangle. Okay. So really, I'm using the same measurements as we did for the previous slide. I've just rotated the triangle around. So I'm still going to, in my 30, 60, 90, my hypotenuse is still going to be 2. The side that's by the 30-degree angle is going to be square root of 3, and the other side is going to be 1. Okay. But again, for my triangle in my unit circle, I can't have a hypotenuse of 2. I have to have a hypotenuse of 1. So again, I have to divide by 2. So now I have the 1/2 and the square root of 3 over 2 that have just kind of flip-flopped locations from my previous triangle. So instead of going over square root of 3 over 2 and up 1/2, now I'm going over 1/2 and up the square root of 3. Oh, square root of 3 over 2, sorry. So that's going to be my terminal point for the pi over 3. So it's basically the reverse of pi over 6. Okay? So this is what we just talked our way through. This is what we kind of proved, or what we showed, that these are our terminal points for pi over 6, pi over 4, and pi over 3 on our unit circle. Okay? So if you go a distance of pi over 6 on the unit circle, that xy value is represented here in your terminal point. Okay? So now, if we go around the unit circle the rest of the way, I don't want to have to do these 3 algebraic, geometric thinking, thought processes, proofs for the other 3 quadrants. I'd have to do them 9 more times. I don't want to do that. And luckily, we don't have to, okay? Because there's a relationship between these terminal points in the first quadrant and those terminal points in the second and the third and the fourth quadrant. Basically, all we have to do is change their signs. So if I want to do that then, to fill in the rest of my unit circle, remember that I have to, okay, if I'm in the first quadrant here, remember everything is positive, positive, okay? So if I want to find, let me draw in pi over 4, okay? Now pi over 4 in the second quadrant isn't really pi over 4, okay? Pi over 4 is in the first quadrant, so that's a 1/4. This would be 2/4. This would be 3/4. So this is 3 pi over 4. So if I want to find the terminal point for that one, instead of going to the right and then up square root 2 over 2, I'm going to go back the square root of 2 over 2 and up square root of 2 over 2. Okay, so it's going to be negative square root 2, well, 2 over 2, and then square root 2 over 2. And if I wanted to find that in the third quadrant, okay, to get to this point, I'd have to go back and I'd have to go down. So both of my values are going to be negative. But it's the same distance. And then in the fourth quadrant, okay, that would be 7 pi over 4. I'd have to go over to the right and then down. So I'd have square root 2, oh, 2 over 2, but then negative square root 2 over 2. So it's going to be these same ordered pairs for all of the similar corresponding little slices. So all the pi over 6's are still going to have, oops, all the pi over 6's, they're still going to have these values in their terminal points. They're just going to change signs. And all the pi over 3's, they're still going to have these values for their terminal points. They're just going to change signs because they change locations. And the signs are going to change according to the signs for that quadrant. So the first quadrant, everything's positive, positive. Notice in the third quadrant, everything's negative, negative. In the second quadrant, everything is negative, positive. And then in the fourth quadrant, everything's positive, negative. So if we went around the unit circle and we filled in all of our corresponding ordered pairs for our terminal points, we would get this. So this is what your unit circle should look like. Okay, it's got everything labeled. It's got the stuff we labeled yesterday. It's got the stuff we've talked about today. It's got your degrees. It's got your radians. It's got your terminal points. And notice that these terminal points, they're going to be the same for the degrees and the radians. So if I say, what's the terminal point for 60 degrees, you would say 1/2 square root 3 over 2. If I said, what's the terminal point for pi over 3, it's still 1/2 square root 3 over 2. Okay? So there's going to be a lot of mental skill that you have to use, a lot of detail that you have to remember, but luckily there's patterns. Okay? There's a lot of repetition, and you could reconstruct this on your own if you needed to. I recommend, though, if you want, print off the picture from this slide. Copy it and paste it into a Word document and print it off. Or do a Google search for unit circle and you'll find this picture. Okay? So have this handy so that way when you're doing your homework, you can have it beside you. Try and do the mental work in your head. Okay? Try and get it down mentally in your head, but have this there just to kind of double check too. Okay, so now that we have our unit circle officially complete, we're going to use it now. Okay, so we're going to find the actual terminal points for 3 radian measurements now. So yesterday when you were finding the terminal points for radian measures, we talked about moving clockwise or counterclockwise. Okay, we're still going to do that today, except now we're not going to end on nice axes terminal points. We're going to land on some of these new terminal points that we've been discussing in the previous slides. Okay, so negative pi over 4, okay, is going to be down here, 1/4. Okay, it's like negative 45 degrees. So pi over 4 is 45 degrees. It's negative, so we're moving down. So we're halfway between our axes. Okay, and if you want to look at the previous slide, you can see that's 7 pi over 4. So it's the square root 2 over 2 and the square root 2 over 2, except the first one's positive and then the second one's negative. Okay. So we're going to be at square root 2 over 2, negative square root 2 over 2. Okay, so remember that all the fourths, all the 45-degree measurements around the unit circle, okay, those are going to have the square root 2 over 2's in them. So pi over 4, 3 pi over 4, 5 over 4, 7 pi over 4, all of those are going to have the square root 2 over 2's. So just kind of think 2 and 2 is 4. The denominator is going to be 4 pi over 4. Okay, so it make a lot of those little mental tricks, little mental connections to help this sink in. Okay. Now for part B, we've got 3 pi over 4. I always like to draw just a little axis and kind of draw in my unit circle where I'm going. Okay, so 3 pi over 4, let's say I'd have pi over 4, that's 1 pi, 2 pi, 3 pi over 4. So I'm right here. Okay, I'm at that 45-degree angle, but I'm in the second quadrant now. So it's still going to be square root 2 over 2 and square root 2 over 2, except I have to be negative and then positive to get to that point. So negative square root 2 over 2 and then positive square root 2 over 2. So it really is that simple and that straightforward. Once you do that geometric and algebraic work to understand where those numbers come from, then you just remember the numbers. Okay? And then for part C, we've got a negative 5 pi over 6. Okay, now remember, pi over 6, that was 30 degrees. And we're moving 5 of them. So we're doing 5 30-degree increments, and it's negative. So we're going down 1/6, 2/6, 3/6, 4/6, 5/6. So we're right there. Okay? So that's going to be 7 pi over 6, actually, is where it is on the unit circle. Okay? It's 210 degrees. Okay? And so it's going to be, if we look at our unit circle, okay, it's right here. And the pi over 6s are always going to have the square root of 3 over 2 and then the 1/2. Now the way I remember this is you kind of count down a little bit, I guess you could think, as you go from your starting point. Okay, as you go up, your denominator in your radians is 6 and then 4 and then 3. So you kind of count down like 6, 4, 3. And it does the same for the values in your ordered pairs here. Okay, in your terminal points, you kind of have a 3 in your numerator and then a 2 and then a 1. So you've got 3, 2, 1. Now granted, it's square root of 3 and square root of 2, but you're still kind of counting down. 3, 2, 1. So that's kind of how I remember that. The pi over 6 goes with the 3 because it's a 3, 2, 1. Okay, it's the first ordered pair that you get to as you go up. So I'm still going to have that value, but in the third quadrant, they're both going to be negative. Okay, so, whoops, I went too far. So I'm going to have negative square root 3 over 2 and then negative 1/2. Okay, so this is just the book explanation for how they got those values as well. Okay, so again, they're drawing a unit circle just like we are. Okay. So again, your homework to practice these concepts is relatively short. Okay, they're odds, except for number 22, so you can check them in the back of the book. And remember, I'll have the solutions worked out in the classroom as well in the binder. So if you have any questions, you can look at the solutions in the binder, or you can come see me before school. But definitely practice this stuff. Try and get these concepts in your head as much as possible. So that way it's a lot of mental math, but it's a lot of quick, non-calculating math. Okay, and if you have questions, come on in and see me.